Hello, everyone. Can you hear me okay? In the back? Good? All right. So today we're going to talk about how to deploy scalable and responsible AI. We have a great integration with Akamai, running AI models on the Akamai Cloud and being able to expose them as APIs and be able to apply the security, the governance, all of those layers. And that's what this talk is going to be about. There is a demo at the end. I may speed it up and might show the demo sooner so you guys at least can see some of these concepts at work. But let's go ahead and get started. Cool. So there's going to be a few definitions that we're going to talk about. So we have this slide just to kind of level set on three things we're going to talk about. First is AI inferencing. The simplest definition of AI inferencing is that you're using a trained model to answer questions about data that you feed it. Okay, so it could be like, for example, a sentiment model where it's already been pre-trained and you're just asking it a question and it's going to give you a response, right? So this is the trend of, we all talk about LLMs a lot, but if you go to Hugging Face, for example, you're going to see over 1 million, almost 1.5 million models that are available, right? So how do you bring them into an infrastructure supported by CPUs and GPUs? That is inferencing. APIs, I don't have to explain this. Think of that just as an interface. It's going to become relevant in the context of AI inferencing. And AI inferencing is going to be consumed and is being consumed as APIs. So this linkage is important. And then the last one, there are many different definitions of API management. For the purpose of this talk, it encompasses a workflow of creating an API, publishing an API, securing it, being able to expose that through a developer portal. And it brings multiple elements at an architectural, at an infrastructure level. To do API management, you will need most likely an API gateway. You may also need an AI gateway. That's becoming the new deployment pattern. You will have some kind of a portal, and then you're going to have a control plane and an administration plane. So it's a bunch of things put together. This, some of you may already be familiar with, AI.
Line-wide internet AI gateway.
We'll talk about that. The question is, why do you need an AI gateway? Hopefully that will be clear at the end of this. AI inferencing is on the rise. Lots of stats here. There's a shift happening from trainings, creating AI models, to using AI models, right? So inferencing is about using AI, whereas training has been about creating AI. So this just kind of shows the trend is growing here. And this is where the partnership and the integration with Akamai makes a lot of sense, because you're going to be able to bring all of these models running on the Akamai Cloud and exposing them for maximum consumption. So if you read the top line here, this is what's happening in the industry. The more AIs you have, the more AI models you have, is going to create the need for more APIs. And the more APIs you have, that creates the need for more API management. AI models being consumed as APIs, this is becoming the new deployment pattern, which means there are lots and lots of AI endpoints. And this requires real thought around how you're going to manage those endpoints, because you may test out a lot of AI models, doesn't mean you're going to keep them on for a long time. So lifecycle change management is going to become a big problem. So you need the right infrastructure, you need the right workflows to bring in AI models, test the AI models, push them out to your users, get feedback, and then keep iterating. And so you need the right infrastructure that allows you to do this in a seamless manner. These are the three challenges that we are hearing from users, the ones that are really going further down the AI path. The first is the versioning challenge. So let me explain what this means. When you bring in AI models and you're exposing them as APIs, the external interface is, let's call it an API contract, right? So you go into any API portal, you will see the API, the endpoint, let's say is /v1. So your application is connecting to that AI model through that API interface. If on the back end, your models switch out, so let's say you're using a Gen 1 model but then you want to switch it out to Gen 2, or you want to do some kind of canary testing where you want to load balance across different models. If you don't expose, first of all, if you expose the endpoints directly to the application is going to break when you're switching out the endpoints. So what you need is an abstraction layer where you expose those endpoints as APIs, you hit the API, and even if you're switching out the models on the back end, it doesn't matter. Your API contract, which is your kind of policy to your consumers, stay intact. So this is one challenge we see where you need an AI gateway and you need an API management working together to solve this. Second one is around scalability and cost. This is where you need semantic caching, for example, to do this at scale. If you are hitting an AI model, you're asking it a question, you don't want it to always go back to the GPU and answer. Like if it already knows the type of question, has an answer readily available, there's no reason to spend those extra cycles. And this is how you can get scalability and you can get better costs. So this is where the AI gateway helps. It acts as a caching layer. Third one is what we call responsible AI. This is where we have a feature now called ContentGuard that controls the inputs and outputs to an AI model. So let's say if you want to put a policy in your enterprise that says, do not share personal information with the AI model, like social security numbers, email addresses, date of birth, all of that. You can put that policy in place. Or you can put a policy in place saying when the response comes back from an AI model, let's say you have a custom trained AI model that has your corporate sensitive data, you don't want that to produce certain things that may be private. And so you can do masking of the data when it comes back. So you can do blocking, you can do masking, or you can do some combination of the two. So this is what we call responsible AI. Back to your question, this is where you need a gateway. You need an AI gateway to be able to address these challenges and enforce scalability, responsibility, and be able to do some of the versioning challenges. So I'm going to zip through this because there's additional data here. This is just to show you there's a reference architecture that we have put together on Akamai Cloud. So you can run everything I just showed you, you can run on the Akamai core where you would have our gateway running. You have the inference models running in Akamai core, and you can expose them as APIs, or you can run them in the Akamai distributed compute. Same thing, you can bring your inference models, run them there, and you're able to expose them as services.
Is this a cloud service that you offer, or is this a self-hosted?
Cool. The question is this a cloud service or self-hosted? So we provide the gateway. The gateway is kube native. So anywhere you have a Kubernetes infrastructure, you can run it. So we're running this inside of LKE, which is Linode Kubernetes Engine, present in Akamai. But you can run this on any Kubernetes environment that you want. So we provide, let's call it, it's not a SaaS, it's on-prem, but your on-prem could be on the cloud. It could be somewhere else. Here's what I'm going to do. So how do you get started? If you want to run this on Akamai, it's extremely simple. First thing you have to do is go and create a cluster. So create a Kubernetes cluster, and then you will install Traefik, which is the gateway, and then you bring your models in there, and then you can pretty much expose them. So I'm gonna show you a demo next, and there's going to be two separate demos. The first demo is going to be about. So I have two models that I'm running. I have a sentiment analysis model that I'm running on the Akamai Cloud, and then I have a chat completion API model that I'm running. And when I walk you through this, you will see how the semantic guard comes into semantic caching comes into play, how the content guard comes into play. You will see when the cache is hit, when the cache is missed. So hopefully it will explain some of these, but I'll kind of do a voiceover. So let's start with the first one. So let me just pause this real quick. Come on. Okay, so the way this is built, I have chosen my model. This is just a homegrown UI. Okay, so I'm choosing the sentiment analysis. What you're going to see here are different values, whether things are actually getting activated. And here, I'm just going to give it an input and see what response comes back. Oh, is that the normal? All right, let's try this again. So I'm going to give it an answer, a question or a statement. This pizza was great or tasted great today. I hit submit. I'm going to get an error. This is the first thing you can, because you're exposing an API, you put an authentication in there. So I put an API key. I run it again. I get an answer. And this is just a model. This is inferencing in action where the model is responding. I do another, salty and dry. I get a different response. I'm going to switch it up again. Pizza tasted terrible. And it's a bigger negative. Now let's show you the next demo. This is going to be a chat completion one. And this is where you're going to see ContentGuard and Semantic cache in action. So I'm going to ask, who's the first president of the US? Okay, same thing. I forgot to put my API key in. I go ahead and put that in. And you see, it masked because I gave it a policy to mask any kind of date time coming back. So it's still giving an answer, but it's redacted the sensitive information that you deem sensitive for your organizations. Now I'm going to ask the second question, and you see the cache was missed. This was not in the cache available. Now I'm asking a different question. Who's the most famous rock singer? Okay, I got a bunch of stuff, but things are redacted again. So you're getting it. This is responsible AI in action. And here, cache is missed. This was not in the cache. ContentGuard passed. This is the vector DB, the representation of the distance. Now I'm asking a slight variation of the first question. You see the cache is hit. Token used is 0. It did not need to go through any additional processing. And you got the same response, masked. And the duration was smaller. And now the last example here is going to share some personal information to the model, and we're going to block it. This is an example of a block, not a mask. So I just say, here's my email address. Do you need any more information? You hit submit, and it blocked it. ContentGuard says blocked, and that was it. So no data went in that you wanted. All right, so let's see. I think that was it. So I'm going to end with this. The joint integration that we have put together, it's Cube native. So you can freely deploy it anywhere across the Akamai Cloud, wherever it allows you to deploy LKE. This also allows you to do inferencing everywhere, specifically at the Akamai core if you wanted to, depending on how much bandwidth and how much CPU and GPU power you need. Or you can do it at the distributed compute. And everything that we do, although I showed you a UI example, under the hood, everything is a YAML file. And we're doing everything in a fully declarative as code approach. So you can employ your CI/CD pipeline to deploy everything at scale. You can do GitOps. You can write your linters if you want to check for things. The way you kind of do pull requests, it works in a native declarative way. And that's it. Thank you.